Hi, kids. It's Crazy Bob. And what's Crazy Bob doing? He's sitting in the dark. Yep. Well, actually, I'm sitting in the dark so I can show you what these LED readouts look like. Because when you turn the lights on, they get all washed out on the camera. They're beautiful in person, but they get kind of messed up when the lights are on. I'll show you what I mean. Stand by just about, well, half a second. All right. I don't know if that was half a second or what. Anyhow, yeah. Crazy Bob did it again. Winter's here. I got all the decorations up outside. I got 19 windows with candles in them. I pulled up the remains of the vegetable garden. I think the yard's all set. I had to cut down a big old maple tree, which was the south end of my 80-meter dipole. That kind of made me unhappy. How fast can I grow a new tower out there? Well, we'll have to figure something out. Anyhow, that's my problem, not yours. Here we go. AM receiver. You know I love AM DXing, AM broadcast DXing. This receiver could be any band you want, but I picked that for starters because it's the most dense electromagnetic band that we have. Just think about it. A little over 1 megahertz, and it's just jam-packed with flamethrowers, 50,000 watts every 10 kilohertz. Can you imagine? Oh my God, and they talk about renewable energy. Anyhow, up here on top, just for reference, is the old AMX4. And if you look back a couple of months in my YouTube, you'll see the AMX4, and at the companion, I did an FMX4. They're matching twins, AM and FM. However, when you're tuning AM, they're 10K channel spacing. I left off the last zero for savings, if you remember that. So we're looking right now at 960 kilohertz up here. Because you don't need the zero, because every time you change the station, that's going to go to 970 and so on. And if you go into the megahertzes, where's the thing? Flip the switch, and then you have one, and you won't get anything at 9, but you go to 1760 or whatever you're doing there, okay? All right. I decided that's really confusing, because it still looks like 76 what? I don't know. It's supposed to be 760. All right. Bob decided he had to fix that. Sorry for giving you the finger there. So let me show you what I did. Hang on another half second. All right, here's what I did. I added the zero. Now you can see we're at 960. You could also see everything is marked, so you don't get all confused about what you're doing. I made it a little easier to go to 1 megahertz. And what do you do with this last zero? Because in America, that's the United States of America, in North America. We're in the middle of North America. We got people up north and people down south. But here in America, we have 10 kilohertz on the zeros for the AM band. So that zero isn't necessary, as you saw with the AMX1. You will notice I'm calling this the AMZ1. Why? Because I ran out of letters. No, because I think this may be the last AMR I built for a long time, and I'll tell you why. Because I'm crazy and I ran out of technology. And in fact, there's not much more I could do with these. I sold one of the last ones. This one, somebody may want it, maybe not. If they do, I got to build another one because they ain't giving this one up. Anyhow, we got the last zero. I put a knob in here that says lock open. And that refers to the phase lock loop down in here on the board. We'll get to that later. If I open it, everything goes dark. Why? Because you can't tune. It's like a TRF now. It's going to pick up the closest station that's around. And let's just do that. Let's put some audio.
Recovery to this point, and just because
all right, there's 960, and
sobre todo cuerpo enfermo, se va la ceguera, se va la invalidez ahora.
You heard that Spanish station. That's a flamethrower right across the river from me, about 2 sparrow miles away. And when you unlock the phase lock loop, it's going to latch onto the, it's just like FM, it'll latch onto the loudest thing, and you just saw that. Okay, let's get into this quickly. This is a lot like the AMX4, but I added some stuff. And the reason is, instead of being 1 unit high, it's now, voila, 3.5 inches high. Try to sneak it into the family room. Maybe she won't notice there's a bigger radio with more lights on it, and maybe well, don't tell Mare, okay? Just don't tell her. We added digital readout of S units. I'm sorry, signal strength, and that's in microvolts. Very nicely calibrated. I put a meter in. People like meters. Some of the old-fashioned guys, the legacy guys, you gotta have meters, Bob. All right. So you can glance at the meter, and you can see we're just over. Can we focus, please? It ain't gonna, is it? It just ain't gonna focus. Well, it's an S meter that reads. I know why it ain't focusing. It's looking at all the lights. It's calibrated in microvolts and S units. All right. And let's scoot over here. Volume units, recovered audio, average, and peak. Now don't forget, I'll explain the philosophy of that. If you don't recall my other videos, I'll explain that to you. No, I'm not light crazy like 42nd Street, New York City. There's a reason for that. Recovered modulation. Again, we can't focus, but we're up near 100. And instantaneous over here. And you can see as we approach 100, I need my tool. Let me get my tool. From here, average, to here, peak. Average, peak. Now, one more modulation thing. We got all the way back. To accompany signal strength, average modulation in percentage. Bob, you've got 3 modulation indicators. Yes, I do. Yes, I do. I have. Why do you do this? Why is he trying to do this with his left hand? I read out the peak reading, average reading meter. Okay. Traditionally, in the control room of a radio station, if you're monitoring your broadcast or monitoring the competition or the adjacent channel station, or if you're out in the radio van and you're doing signal strength measurements and proof of play and proof of performance out there in the field, you're going to want to read meters and make notes in your logbook. If this thing's installed in a control room in your broadcast station, you're going to want to look through the glass window 20 or 25 feet away and see that everything's okay. I said that with one breath. Is my humor lost on you? I hope not. Okay. That's where the idiot lights started. 1, 2, and these 4. I'll get into what those are. Request from, I'm going to say, I can think of 4 or 5 chief engineers, and I know there's more, and I don't remember their names. One's in Arizona. I got another guy in Colorado. There was a guy in Utah. I don't even know if he's still alive or not. An old-timer, a great guy. Anyhow, they wanted idiot lights. We're tired of reading gauges all day. We're working 12-hour shifts or however long the station's on the air. Usually they're on the air by 5 or 6 in the morning. Then they go on through drive time. Then they go into syndication and robo status or something like that. He says, I just want to, on my way to the men's room or the cafeteria, I just want to walk by and look at the lights and see that everything's okay. I don't have to go in there, put my reading glasses on, and read the stupid meters. Red's bad, green's good. Everybody knows that if you drive a car. All right, what are these? Some of these. We are gonna focus. I really wish. All right, signal, pass or fail. If you lose transmitted power for more than 5 seconds, you're going to get a red light. Here, let's do that. Shut the signal off here. Now simulate it. And let's see what happens. There we go. Blink, blink, blink in red. Oh, God, you never want to see that. All right, shut that off. The detector. This is detector activity, just to show that you've got dancing candles here. And they're happy. You know something's going out on the air. You don't know what, because you don't have the monitor up, but it's going out. Same thing here about recovered audio, the other side of the detector going into the audio system. These are not quite in sync. You'll see there's some latency with them, but you can see how what's from the RF carrier. The carrier is loaded with modulation, or it isn't. Audio is present at the output, or it isn't. Well, it just stopped there for a second. I guess let's see what the guy's doing. Oh, yeah, there you go. Okay. And then finally, the DMOD warning. If you stop, the transmitter stops, and DMOD goes south for any reason, not just pass-fail from RF carrier, but pass-fail from audio on the carrier. So you got the red lights. Maybe you didn't notice them. What's going to happen? Watch this fourth guy here. Oh, the red light's supposed to come on. It didn't. I think I'm low on signal there. Okay. We also put. Oh, by the way, this is calibrated 50 microvolts. Will give us S9 here. We've also built in case you're near the tower making measurements or very far away, both extremes, you have an attenuator in percentages for the RF input. There's a sensitivity control, bad focus. Oh, this is terrible. I should hire a guy to come in and do this stuff. All right, sensitivity, which is calibrated in well, trust me, it's calibrated in dB. And the preamp, going from 0, this is unity over here, all the way around to 15 plus dB, or I should say plus 15 dB. That's if you're way out in the field and you want to cheat and say, well, you know, I really can't, I hear the noise, I can't hear my signal, let's kick in some preamp, get above the noise. You have to record how many dB you have added to either the S units or this, otherwise you'll be cheating. If you flip this switch, it's out of the circuit. You flip this in, all these three are in, flip it out, you're safe. Nothing's working there. Alright, the controls, like we saw, add a meg, lose a meg, binary, go through all the all the things you want. Like I said before, open up the PLL. See the lights went out? That's to tell you opened the PL. Low pass, high pass. If you got a lot of noise or you're doing long-term listening, that makes things life a lot easier. Line level 0 dB is 0 dB to the output that you're going to be taping or sending back to the studio, whatever you're doing with it. Master gain for monitor.
Where the rest of that's coming from? Any thoughts? Yeah, I mean, part of it is
power, and of course the name. No focus, but a name. Okay, inside. Quickly. This is a TFT 930 AM board. It's PLL. It's rock bound. Here's the crystal. Here's the processor. Here's your BCD programming. I brought them out to put some light on. This is upside down because I'm looking into the chassis, but I brought them out. Two little BCD switches down below these connectors. Oh, can you see them? Oh, you see them in there. Well, trust me, they're there. It's just 10 position BCDs. Here's the back of the displays. It looks a little junky because these ribbon connectors are too long. But in fact, the radio's wired pretty nicely, I think. Well, I said so because I did it. Yellow dots. 1, 2, 3. Never touch yellow dots because there's 120 volts there. Nice big power supply, 10 volts and 5 volts, 10 for the analog, 5 volts for the logic. Transformer for that. I've got a separate power supply and transformer here to drive all the lighting. All the 42nd Street has its own transformer because LEDs are power pigs, LCDs are not, but I don't like them. Not a lot of people do in the professional business, and you can't read them across the room 20 feet away. All the secondary boards, the preamp, driver for the S meter, the signal strength meter. These are drivers for the modulation and audio indicators. This here is a NOT gate or an inverter that allows me to do pull down for the BCDs to tune the radio, and level shift, pull up. See my finger going up? Pull up to make the digits change on the front. Unfortunately, if they were all pull downs, I'd be happy. I wouldn't need that board. But what do they call them? A NOT board, right? A NOT chip? Indoor, not nor. I don't know. But it's a level inverter. And then some meter drivers down in here. What those are just constant voltage op amp circuits. So it's all pretty simple. It's just there's a lot in here. And I was worried I was going to run out of juice from the power supply because of all those things going on. But there it is. It works nice. Really works. It sounds good. We'll go to the other local guy here. See? And I don't know. What's more to say? I really hope the guy wants this, and I'm going to tell him, look, you borrow the prototype and play with it, and if you like it, I'll get you a brand new one, because you can't keep this one. And then this goes back into the family room. All right, that's it. I went long. I always do because Bob talks a lot. Here we are at the end of 2000. I hope everybody's COVID safe. Nobody caught the Chinese virus yet. And we adjust and moderate our social interactions until we get through this thing. Maybe get a vaccine. I don't know what's going to happen, if it'll make you safe or you end up growing a tail and pointy ears and hair on your kneecaps. Whatever. Okay, stay safe, be cool, and if you like, give me a thumbs up. Please subscribe. If you don't like it, just go away quietly. I'll have some more stuff for you to laugh at. Bob N1KPR on YouTube and www.bobsamerica.com on the what's that thing called? Oh yeah, internet. Take care and bye-bye.